So in another video we talked about how we can build these algebraic functions, or we can do algebra on functions to make other functions. So one thing to note is, what if we want to find the domain of these functions that we built? And here's 4 different ways we can build them that we've been introduced to so far. And a thing to note is domain is where does the x or the input values exist. And so a thing to note is we can make these different functions and find the domain of them individually. Then we have to note that this one, the domain is going to exclude where g of x is equal to 0. Well, let's think about that. We can't divide by 0, right? So, since g is the function in the denominator of this fraction, wherever g of x is 0 would cause that. So we have to exclude those values. So let's give an example. Let's say we were looking at 2 divided by x minus 4 and g of x equal to x minus 6. So we have these two functions. So if we want to add the two functions together, f plus g of x, we would get f 2 divided by x minus 4 plus g x minus 6. And our domain, well, in this case, do we have any restrictions? There is one. The main restriction would be, hey, where does this point equal 0 in the denominator? Well, that point is when x is equal to 4. So we're going to exclude x equal to 4, but any other value in this function is okay. Let's take a different f and g. Let's say, for example, we have x squared plus 1, and g of x is equal to 2x. Well, if I want to know the domain of f minus g, x squared plus 1 minus 2x, this gives me a function of x squared minus 2x plus 1, just writing in descending order. Do we have any values that could possibly make us divide by 0 here? No, and there's actually no values that are restricted in this type of a function. Therefore, our domain would be equal to all real numbers. But if we take those same two last functions, f and g, and say we wanted to do a divide, well, f is x squared plus 1, and g is 2x. So now we have to ask ourselves, where's the issue? Well, the issue is where g of x is equal to 0. This happens to be when x is equal to 0. So our domain is going to exclude where x is equal to 0. Let's say we were talking about the same idea of the divide, and we were given the functions x squared plus x instead of plus 1, and g of x is equal to 3x. So really similar. And we created a divide. So we have x squared plus x over 3x. They all share an x in common, so one of the x's cancel, and I'm left with x plus 1 over 3. Here's something to note. We'd look at this and think, hey, no restrictions on the domain. But we have to remember, even though x's cancel, we have to go back to what we originally built the functions out of, and therefore we have to make it so where does g of x equal 0, because we can't have that. So the domain in this case as well would also be x cannot equal 0, because that would cause a divide or make g of x 0, which would be what our denominator is built from.